Hello everybody, my name is Kenneth and today I'm back with another AP Micro video, and in this video we'll be exploring inefficient firms, which comes after the perfect competition model of a market that I explored in the last video, so you guys should check that out if you're unaware. So let's get into it. So first I want to talk about monopolies, and you've probably heard of a monopoly before in maybe a history class, and if you have, it's probably been Standard Oil or something like that. And pretty much what these are is there's only one firm in the market, which makes it the monopoly. So let's jump into the graph. Now, something else I would like to say is that these firms are price makers. Because there's only one of them, they can make the price whatever they want, really. As long as people are willing to buy it, they can sell it at whatever price they want. So here's the graph of a monopoly. And one thing you'll notice that's different from perfect competition is that MR does not equal demand, average revenue, or price, right? You can see these aren't equal. And I got this graph from Review Econ, so you should check out their stuff if you want to. And pretty much the reason that MR branches off from these three here is because as you lower the price of the good, and a monopoly has to sell more of a quantity of a good, the monopoly has to lower the price of the good. And the reason that marginal revenue branches off is because as you lower the price of the good to sell a higher quantity, you have to lower the price of all the goods you sell before it, right? So say you sell two goods here for $10, and then then here you'd sell three goods for maybe $8, and you have to lower the price to $8 for the first two goods as well, which makes the marginal revenue lower each time the price goes down. So the marginal revenue will be less than the price. Okay, so where will a monopolist operate on this graph? Well, you're still going to follow the golden rule, quote unquote, which is to produce where MC equals MR. So they're going to produce here. As you can see, it kind of says the profit already, but I'll get into that. So you're going to produce at this quantity, but since the price is not equal to the MR, as I just said, you might be confused as to where the price is. And you might think that it goes from across where MC and MR are, but that is not the price. The price is instead where the demand curve is, and a lot of time, if this graph is drawn out, this will say demand. And then you'll go off here to where it's labeled on this graph. Okay, and then to find the profit, it's going to be the same as the perfect competition. For all firms, the profit equation will be the same. So it'll be profit equals, well, I guess you could say profit, or sometimes profit's given like this. There's like a 2 symbol in Roman numerals. But I'll just use this. I'll say profit equals price minus ATC times Q. And in this model, since price is higher than average total cost, this is profit. It's economic profit, as the graph shows. Okay, and in this graph, or for this market rather, the monopolists can earn long run profits because there's only one firm. They're not really competing with anybody. One last thing to talk about for this is that this market is inefficient. Because if this market was efficient, socially efficient, like they were socially optimizing their resources, then they would be operating where price equals marginal cost. But since MR is less than price, the monopolists operate at a quantity which is lower than this quantity. As you can see on this graph here, this is lower than this quantity. And so what this means is that, hold on, let me erase this here, is that there will be a dead weight loss from inefficiency in this market. And the way you can tell where the dead weight loss is, I know I just kind of filled it in here, is because it'll be pointing towards the socially optimal quantity, which is where, once again, price equals MC. And then you can find it from this because it'll normally be a triangle for something like this. And then it would just be this area. Okay, now let's move on to monopolistic competition. So in monopolistic competition, there are tens of firms. Sometimes there can be like hundreds. And so there will be like probably around like 50, 20, 30. And there's not many barriers to entry. Something that I forgot to mention with monopolies is that there are barriers to entry in monopolies, and that is not the case so much here. However, the firms do have, well, they can have differentiated products here, which means that not all the products are the same. And because of that, firms can participate in advertising, and they do this to draw more customers for their firm. Now, let's get on to the graph. Okay, so the graph, you can see, well, it's the same image as the last one, and that's because these graphs are pretty much identical. And I mean, that's really what they are. So finding the profit or the dead weight loss, and the reason the MR is not the same as price or demand, well, everything is the same here. So I'm not really going to explain that again. Um, However, something I would like to mention is that for long run in this firm, like perfect competition, this firm is not going to be earning any profits. So I will draw out a graph here to show what is happening. And I'm going to draw it on the side. So you're going to have the marginal costs. It's a terrible curve, but it'll work. Then you're going to have the demand. I'll label this D. And then you're going to have the marginal revenue. And let's keep in mind that the demand equals average revenue and price. Um, and then here's where it gets interesting. So well, first off, you can tell that the firm's going to operate at this quantity because this is where MR equals MC. I guess I should label this MC. But what's interesting for this graph is that the average total cost at this point is not the lowest on the graph. The average total cost is not minimized where the firms are producing. So instead, the graph kind of looks something like this. It kind of might go like this. And I know it's a bad example, but the point is that here the average total cost, and I'll circle it in blue. Here the average total cost is greater than here, which is where it is minimized because the average total cost, if you think back to your curves, is minimized where MC equals ATC. And at the point of production, it's higher than that. But if you still use the profit calculating equation, the economic profit will be 0 for the firm because the price is equal at this point. The price equals the average total cost. Okay, and so the next inefficient firm we can go over are oligopolies. And pretty much in these firms, the AP people, they do something called game theory. So you're not going to see a graph, but I will explain the game theory in a minute here. And in oligopolies, there's only a couple of firms typically. For game theory, there will typically be only 2 firms, but it can range probably from like 1 to 5. That would be normal. And these firms can have differentiated products, and they do perform advertising like the monopolistic firms. But the main thing about these firms is that they're interdependent on each other's actions, which is why game theory exists. Now, it is illegal, but these firms can participate in colluding, which is where they make contracts with each other to operate at whatever gives both firms the best profit. For example, here, that would be this box, where, because both firms are making more profit than if one went individually, because although this one, like say firm A, or this would be firm B, assume for B went to a lower price, it would be making 100 million, but firm A wouldn't, and so firm A obviously would not accept that deal. So if they collude, then they might operate here. However, that's not legal, so you don't really take it into account. It's just something to keep noted. So okay, so then how do you find out where the best place is to operate using game theory? So in game theory, firms will sometimes, not always, have a dominant strategy, but then there will always be a Nash equilibrium. And where the Nash equilibrium is where both firms will operate dependently of each other. And so pretty much what makes a Nash equilibrium an equilibrium is that the total market profit is maximized in that Nash equilibrium, and the firms have no incentive to cheat on each other or to switch to a different strategy, and that's really important. And these are the strategies. So like if firm B lowers the price, that's a strategy. The strategy would be to lower the price. So how do you solve this? Well, let's say here that firm B is the blue triangle and that firm A is the white triangle or the triangle on the bottom. So here, if firm B raises its price, then here it would be making 80 million, or here it would be making 30 million. But that's not really important for firm B strategy. If firm B raises the price, that's how you find out A's strategy. So if firm B raises the price, A can either raise their price and make 80 million or lower their price and make 100 million. So which one sounds better for firm A? Well, 100 million. Okay, so for firm A, they're going to choose this one. So we'll circle that. Okay, now if firm B lowers their price, where's firm A gonna go? I'll let you figure it out. Okay, they're gonna go here. Sorry, that's supposed to be red. Well, they're gonna go here because $70 million is greater for them than 30, so it would make more sense for them to go there. So we see here that firm A actually has a dominant strategy. They're gonna lower their price no matter what firm B does. And that's what makes a dominant strategy. If a firm will do something no matter what, then that is their dominant strategy. Okay, so what's firm B gonna do now? Well, if firm A raises their price, which we know they won't, but for this example, I'll explain. Well, if firm B or firm A raises their price, then firm A raises their price, then firm B can either make $80 million or $100 million. 100 if they lower their price, or 80 if they raise their price. And which one's better for them? Well, 100 million. Okay, so now if firm A lowers their price, where will firm B operate? I'll give you guys a second. Okay, they're going to operate here because 70 million is greater than $30 million. So you can see this box has two circles, and that makes it a Nash equilibrium. And like I said above or before, a Nash equilibrium is where the total market profit is maximized for the firms. And then also, this is where the firms have no incentive to cheat on each other or to switch to a different strategy. And that is all for this video. Thank you very much.